Okay, just as a little review, we're going to be talking about bacteria in this second segment of the video clip for you. And we know that they're single cell microorganisms that have no true nucleus. They reproduce by cell division. And remember, bacteria do not have DNA and RNA like viruses. They produce exo and endotoxins. And again, exotoxins are released during cell growth. They damage the plasma cell membrane. We've got some very well-known exotoxins. There's many more than this, but Clostridium and Staph aureus are exotoxins that actually release hemolysin, which destroys red blood cells, and leukocidin, which destroys phagocytes or white cells. And again, look at the word hemolysin. Lysin means break up. Lysin means to break, where hemo, anything with HEMO, is going to be the blood system. Leuko, anything with LEUKO, is going to refer to a white cell. And leukocidin, again, cytal means death. It's going to kill it. So those are some examples of that. And then endotoxins also come from bacteria, is when the bacteria dies. Endotoxins will cause a fever and an inflammatory response, and they are not affected by antibiotics. So thank God the exotoxins are, or we wouldn't be able to survive bacterial infections. And we know that they're also classified by shape, growth requirements, motility, aerobic versus anaerobic. So now when we look at this, I'm just going to leave you to open it up. I opened it up and went through the video, the YouTube video on immune system and bacteria. It didn't want to load for me. So go ahead and look at it, though. It's kind of like a cartoon version, but it's very, very fun. And it actually, you get to see how many millions of vessels we have, and also hundreds of thousands of cells that actually help us with the immune system. And here's a picture of our gram positive and gram negative, as you can kind of see. I know you learned in microbiology the different shapes and what they stand for, what they look like, and we figure out what's gram negative and gram positive by something that looks like this, culture and sensitivity. And with the culture and sensitivity, we're going to culture the wound, we're going to culture the drainage. We're going to do, if there's nothing draining, there's no wound, but the person is still very sick, they'll do blood cultures. They'll take a sample of their blood, and then we're going to grow it somewhere, a lot of times in a petri dish, and it lets us know if they're gram negative or gram positive. And you've learned a little bit about antibiotics by now to know that there's certain groups that can kill gram negative and certain that can kill gram positive, and that's why we need to know what it is. There are some that will do both, but for the most part, it's one or the other. Okay, so now we've looked at viruses and bacteria. Let's go ahead and look at our fungus. Fungal infections are called mycotic or mycosis infections. Fungus are not photosynthetic microorganisms that are produced by division. They're very large compared to bacteria and viruses. They do contain a true nucleus. They're either classified as yeast or molds, depending on if they're aerobic or anaerobic. They can be part of a normal flora. Remember, we talked about normal flora as bacteria that you'll find in certain areas of the body that needs to be there for our protection. We know that women can get vaginal yeast infections when antibiotics are used, and it can wipe out the normal flora that needs to be there. So we have to be very, very careful with some very heavy-duty antibiotics for women, or a very broad spectrum that will kill the yeast and the normal flora in there. Okay, and I think we already talked about them, what mycotic is. All right. We have parasites that are actually very uncommon except in hot and moist climates, so we're kind of lucky here. We don't see too many parasitic infections in California because we have a dry heat. We don't have the humidity. But we still need to learn about them. They're single-celled or multi-celled organisms that depend on a host, whether it's us or something else, in a protective environment. Most common parasitic infections that we see, the most common are in the intestines, and they're known as tapeworms. And there's just a really big blown up picture of what the trichomonas, which is a vaginal parasite, looks like. So barriers to infection, we've already talked about it a little bit, that can be found in our skin, tens of thousands per just a little area of skin, because skin is a barrier. It protects us from getting sick. Secretions from the eyes, nose, prostate gland, the testicles, vagina, and stomach. So persons with healthy immune systems can usually ward off infections because we have these barriers. We have built-in infection barriers. Secretions that contain bacteria-killing particles are called lysozymes, and those are very, very important and very, very good for us. And then finally, many, many relationships exist between humans and organisms. And here are some common words, some more than others, that you will hear in this class and out in the medical arena. Symbiosis, what that means, it benefits only the human, but no harm to the organism at all. Maintained by immune and inflammatory systems. So we don't hear that a whole lot, because if the benefits are to you and you're fine, you're probably not going to be in seeing a doctor. Mutualism means it benefits the human and the organism. Commensalism, it benefits only the organism and with no harm to the human. So that's another, you're not going to see those three. Pathogenicity is the one I want you to zero in on this page. And it benefits the organism and harms the human being. And those are the people that we care for. They're the people that we're studying in this pathophysiology class. So pathogenicity means it has an affinity for a pathogen and it can kill. So that's what that word means. And then opportunistic or opportunism is benign human organisms become pathogenic because of a diminished human host resistance or response. And what this means is, like in our cancer patients, their white counts are wiped out from chemotherapy, or somebody who's chronically ill. They don't have the fighters that we have. So what ends up happening is the normal flora plus any other bacteria become pathogenic because they have the opportunity to, because their immune system is taking a hit. Their immune system is resisting helping the human being. So that's when we say that the organism or microbe, whether it's a parasite, a virus, or bacteria, is can hurt the person. So mechanism of action for any infection, to sum it up, is that there's direct damage to cell, whether it has to go through the cell membrane and hook onto it like the virus, or how it enters into the nucleus with the bacteria, interference with cellular metabolism, so it doesn't let the cell normally work the way it's supposed to. It renders a cell dysfunctional, meaning they're not functioning as they should because of the accumulation of pathogenic substances. And then there's a toxic production of whatever the pathogen is trying to present. And so that concludes section 2 of this presentation, but please look at that video because it's actually really kind of fun, and it gives you an eye-opener as to when the fighters come in, how they fight, and how awesome our immune system is, if you will. All right, bring your questions as always to class, and I will see you next time.